And so what I want to do next is talk about converting. So on your papers, your notes pages, I actually did type up like the steps for changing between the two. So for instance, if I said like 37 degrees, 12 minutes, 32 seconds, and I wanted that as a decimal. Okay, the 37 part won't change because it's a full degree. We just have to convert this step into decimal part. And so to do that, if we think about our minutes, how many minutes are in a degree? 60, just like how many minutes are in an hour. So we have 12 out of the 60 total. So if you want to write it as a fraction, 12 out of 60. Okay, your seconds. 32 seconds. How many seconds are in a degree? So think, how many seconds are in 1 hour? And so what you'll do is just type those in your calculator and add them together, and that will give us our decimal part. So if we grab a calculator, does anybody need one?
Yes, ma'am. Thank you.
So we get 37.20, depending on how many decimals, let's say I said 4, be 2089 degrees. Okay, so to change into degrees, minutes divided by 60, seconds divided by 3600, we add those pieces together. So let's look at this one. Convert the 105 degrees, 20 minutes, 32 seconds to decimals to the nearest thousand. Thousandth is how many decimal places? Three, because it goes 10, 100, 1,000. Okay, so 3 decimal places. So what happens is the degree part doesn't change. So we still have the 105. We just need this decimal. So you take your minutes and divide by 60, plus we take our seconds divided by, and we just type all of that in at once. So 20 out of 60 plus 32 at 3600. And so we get 105.342 degrees. Okay, let's talk about going the other way. So if I started with this decimal and I wanted to convert it into minutes and seconds. So if you think about how I got my decimal, I did my minutes and divided by 60. So the opposite of divided by 60 would be multiplying. So you will start out, the degree part isn't going to change, so it's still the 37 degrees. You take your decimal, and we're going to multiply that by 60. Okay, and so we get 12.534. So this is like our minutes. So how many complete minutes do we have? 12. Okay, now we need to get our seconds. So this is minutes. If I think about my decimal, how many seconds are in 1 minute? 60. So we just take that decimal and multiply by 60 again. So we have 0.534 of a minute. So multiply that by 60. And we get 32.04. That's the seconds. So you'll round that to the nearest whole number. So that would be 32 seconds, which is what we started with on the original one. So if you have a decimal, you take your decimal times 60, then you take the decimal that remains from that, multiply by 60 again. We look at this example. The degree degrees won't change. It's still 85 degrees. To get our minutes, we take the decimal times 60. So that's 15.78 minutes. So we have 15 total minutes. Then to get your seconds, you take the decimal from that answer and multiply it by 60 again. And we get 46.8. So that's my seconds. Round that to the nearest whole number. So how many seconds? 47 seconds. I want you guys to try a couple on your own. The degree doesn't change. There are 60 minutes in a degree, so that's 8 out of 60. There are 3,600 seconds in a degree. So we type those in all together, add that 8 out of 60 plus 14 out of 3,600. And nearest thousandth, so 3 decimal places, you get 74.137 degrees. Is that one okay? So to go the other way, we multiply. So to get our minutes, we take the decimal times 60. So that's 49.02 minutes. So we're currently at 34 degrees, 49 minutes. Then, to get our seconds, we take that part of a minute times the 60 seconds in a minute. And we get 1.2 seconds, so we would round that to 1 second. Or you could say 0.1 seconds if you prefer. It doesn't matter. No questions? I want to talk about a few terminology pieces again. So yesterday we talked about some, what's an angle and things like that, positive angles, negative angles. I want to talk about coterminal angles. We will use this a lot to make our problems easier. I told you yesterday we can have negative angles, we can have angles bigger than 360, but we would rather not. So coterminal allows us to take those really big or really small measurements and turn them into a more reasonable number. If you think about a circle, okay, or here, let's just even talk about this angle. Let's say I told you this was 45 degrees. If I said I'm going to go all the way around, how far is that? 360. And then if you went back, those would be coterminal angles because they end at the same spot. Now this orange one that I drew, what would the measure of that be? You went all the way around is 360 and then an additional 45, so 360 plus 45 is 405 degrees. So what that's saying is 45 degrees and 405 degrees are really the same thing. If you draw them, they end at the same spot. Or I could do something like this. If you spin this direction, what kind of angle is it? A negative. Okay. So how far would that be? We know all the way around is 360, but I was 45 degrees shy of that. Yeah, so it would be a negative 315 degrees. So negative 315 degrees is also the same as 45 when you draw them. So what we can do is add or subtract 360 until we get just a number between 0 and 360. So if you have a negative, you add that 360. If you have a really big positive number, you can subtract 360. And you could do it multiple times if needed. I'm going to show you an example of that in just a second, but I just want to touch on these two definitions first. Standard position, anytime we draw an angle, we're going to do it in standard position. That means the vertex is at the origin, and the initial side, so the beginning side, is the positive x-axis. So standard position requires a vertex at the origin, your initial side on the positive x-axis. We will always start there, and then we'll spin however many degrees needed. Okay, those are the two requirements that we have to have. So if I said like 270 degrees, where would that go? So we're starting here and spinning 270. How far is it from here to here? 90. So this would be.
Oh, it's just the bottom.
Yeah, it would go all the way down. And since it was 270, you would be spinning.
So clockwise is negative. Wait, no. Oh yeah. No, clockwise is negative. And then counterclockwise is positive. That's my point.
I know. It goes the opposite of what you want to make. So essentially later on, we're going to talk about all of this in relation to a circle. It's a really pathetic little circle. And so it makes a little more sense then that if you wanted a positive angle, you would be going up the circle. And so that's where this notation comes from. Quadrantal angles are angles with a terminal side on an axis. Okay, so what that means. This would be an example of a quadrantal angle. It has to be in standard position, so that has to be the initial side. Terminal side on an axis. So what would this angle measure be? 90. Here's another quadrantal angle. Terminal side is on the axis. What angle would that be? Here's another one. The one we just did up there. What angle is that? There is one more. So if we started here, I spin all the way around. What degree measure is that? 360. So those increments of 90, those are your quadrantal angles because they would end on an x or y axis. They separate the quadrants. Remember back in, algebra, this is quadrant 1, 2, 3, and 4. So those quadrantal angles just break apart the quadrants.
How would a 0 degree angle look?
So 0 would be like the 360 because they're going to be coterminal. But essentially, since you're starting and ending at the same side and you spin 0 degrees, there's just no angle symbol drawn.
So that's how you know if it'll be 0 then? If there's like nothing?
Yes.
Okay.
What would it be if I drew it like this?
Same thing.
Yeah. So you can go around multiple times and you just denote that by spinning around more than once. Good. All right. So let's practice finding some coterminal angles. This is a skill that we'll use anytime I give you a really big or a really small angle. So if we wanted to graph it, intuitively when I look at 1,106, I don't have a clue where that goes. But if I wanted to make it something more reasonable, what would I do? Subtract 360. Okay, so if I just subtract my 360 from that, What do we get? Is that enough? Do we know where to go from there? Nope. So we just repeat. So if we subtract 360 again, 386. Is that enough? Nope. So repeat. You don't necessarily have to show me the work. You just have to keep subtracting. And what do you get? 26. So this is like a 26-degree angle. Your goal is to have something between 0 and 360 at the end. If you drew that, I didn't ask you to, but your standard position, so we have to have a vertex at the origin, initial side on the positive x-axis. 26 would end about where? Which quadrant would it be in? Quadrant 1. We know that's 90, so halfway would be 45, so it'd be less than half. How many times did it go all the way around? Subtracted 360 3 times, so it would have gone all the way around 1, 2, 3 times, and then back up to our 26. Now, the only time I would ever ask you to do this is maybe on tonight's homework assignment. After that, if we ever need to draw this, I would just have you draw the 26 degrees, because that's all we really care about is that coterminal piece. Negative 150, what would you do for that? And what's that give us? 210. Good. And that's between 0 and 360, so we're done. If I asked you to draw that, 210 is in what quadrant? Third, because it's between 180 and 270. Because this was originally a negative, which direction was it spinning? Below. So that would be like a negative 150. You guys do C, negative 603. You don't have to draw it, just find the coterminal for me. What'd you get?
I blew it up.
Did you type the wrong thing? Oh, this is still negative.
Okay.
Yeah, so you have to,
The bottom of it,
you add 361, so negative 603 plus 360 gives us negative 243. Still negative, so you have to add 360 a second time, and that gave you the 100.
oh, so I was saying added in there.
Yeah.
Okay.
So you just dropped a negative all the way. Alright. Is this stuff okay? One last type of problem and then I'm done. Periodically throughout this class, we will need to, come on in. We will need to convert things. And so I just wanted to start, we're just going to slowly introduce problems like this and kind of periodically spiral back to them. So this is just the first time. There are different approaches. Some people can just look at these and they know I just need to push some buttons on my calculator and they know what to do and it makes sense to them and they can give me an answer, and that's fine. Some people have to write out all the steps, and so that's fine too. I do it kind of like, I think Mrs. Delaporte does like unit conversions in her science classes. So I try to set it up like that, so it's something that you've seen before. So this one says, a wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of the wheel move in 5 seconds? Okay, so currently, I'm talking about revolutions in 1 minute. I want degrees for my ultimate answer. Okay? So, like I said, you might be one of those people that you just know what you need to do, and you do that, and that's fine. I'm going to set it up like this. 270 revolutions. Per is like dividing minute. Okay. First of all, I need to get to degrees. What does a revolution mean? All the way around the circle. How many degrees is that? 360 degrees. Okay. So I want to convert my revolutions into degrees. We want these revolutions to cancel out, right? So if it's on the top, where do I have to put it to cancel? The bottom. So we want to get rid of the revolutions. We want degrees. And we said that 360 degrees is equal to 1 revolution. Have you seen things set up like this before, like converting inches into miles and things like that? Maybe, maybe not. Yeah. Okay. So what happens right here? These revolutions cancel out and they're gone. So now my units are degrees per minute. Do I want minutes for my final answer? No. I need to get to seconds. So my minutes are on the bottom. To cancel them, they need to go to the top. If you girls need me, I'll be done in just a second.
Oh, I just came in here just.
You're just along for the ride?
I'm
Okay. So what's the conversion between minutes and seconds? 1 minute is equal to 60 seconds. Okay, so then since my minutes are on top and bottom, they would cancel out. We're trying to cancel out these units.
Wait, why did the minutes get canceled out?
Because I have minutes on the bottom and on the top. We're just multiplying all this stuff together. So anytime you have a unit on top and bottom, whether they're right next to each other or separated, you can drop them out. What is the only other piece of information we're given in the problem? 5 seconds. So we are just going to multiply by 5 seconds. So what will actually happen to my seconds? They will cancel out. Okay, my question was to find how many degrees. If you look at this, what's the only unit left? Degrees. So that would be my answer. So what we have to do is multiply all this stuff together. So I have 270 times 360 times 5 on the top. On the bottom, I have 1 times 60, which is 60. So if I divide that, I get 8,100 degrees.
How the heck would anybody be able to put that in calculator?
So, okay. Some people just think a revolution is how many degrees?
360.
So you take 270 times 360. That gives you your degrees. Okay. That was in 1 minute. So to figure out how many seconds that would be, you have to divide by 60. And then we were spinning for a total of 5 seconds, so then multiply by 5. And you get the 8,100. I prefer to write everything out because I like to see the units canceling and it makes more sense in my head, but.
I was hoping I was one of them people that would be able to do it the easy way. But I'm not.
Well, join the club. I think most of us are here. Alright. One more. CD players always spin at the same speed. Suppose a player makes 480 revolutions per minute. Through how many degrees will a point on the edge of the CD move in 2 seconds? You guys want to try it on your own first? Or do you want to just jump in together? Nobody has an opinion?
I said we do it together.
Alright. So we are currently 480 revolutions per means divided by minute. My question asks how many degrees, so I need everything else to cancel out. So first of all, if I want to change revolutions into degrees, so I need to get rid of revolutions since this one's on top. I have to put it on the bottom. And what's the conversion?
360.
One revolution is 360 degrees. Okay, so that's good. That would mean the revolutions cancel. The other time that I'm given is seconds, so I need to get rid of these minutes. Since this minute is on the bottom, I need minutes on the top to cancel it. We want seconds. And what do we know? So then, these minutes would drop out. Okay, currently I have degrees per second. My ultimate goal, I only want degrees, so what else do I need to do? It's spinning for a total of 2 seconds. I'm not converting that. I'm just multiplying it, and those seconds would cancel since it's on top and bottom. So now then you just have to do 480 times 360 times 2 and divide by bottom. 1 times 60 is 60. It's really sloppy. We get 5,760 degrees. Alright. Are we good there? So, let's talk about homework. I gave you guys 8 problems yesterday, right? We stopped at 41. So let's add, let's do 51, 57, 63, 61. So I'm trying to do a couple of each type that we've done. 79.